Hello, welcome to the Semantic Modeling Overview. My name is Tyler Redman, and today Lydia Kaler will be walking us through the details of our semantic modeling offering. But before we do, I'd like to take a few moments and share how Clairview helps all of our customers. Clairview specializes in end-to-end BI services. Our full range of service offerings gives us the ability to solve nearly any business challenge. From assessing your current state of BI maturity to our pre-packaged omnichannel solutions, we can help you turn insight into action. There are many more details out on clairview.com, including webinars like this one. But now let's turn it over to Lydia and focus in on semantic modeling.
Thanks, Tyler. Let's first look at the agenda for today's session. We'll set the context for how information flows in an enterprise data warehouse environment. We'll then look at that architecture and talk about the purpose and benefit of the integrated data layer and why a separate access layer is really needed. We'll then review benefits of Teradata's approach for the access layer and finish with time for questions. To set the context for where the access layer fits into the information workflow, let's review Teradata's Reference Information Architecture, or RIA. The RIA is a high-level blueprint that defines the components and conceptual structure for building an integrated analytic environment. The approach is tool-agnostic, and Teradata and Clairview strongly advocate the use of the RIA, regardless of the warehouse platform you are using, to ensure that the environment is built to a professional standard. In the diagram, data generally moves from the left to the right. The first layer is the acquisition layer seen in red. Its purpose is to gather data from the multiple source systems and serve as input for transformation processing or discovery. The second layer is the integrated data layer, seen in purple. It is the physical instantiation of a logical data model, which can be created using a Teradata industry data model as the reference model, or it can be custom built. Its purpose is to store data in a single integrated data format designed for data integration and data retention needs. In other words, its purpose is to define a model to quickly and accurately get the data in. As a result, the integrated data layer is typically, although not always, modeled in third normal form. The third layer is the access layer, seen in orange. Its purpose is to present data in a consumable format to the end users via the delivery layer. In other words, its purpose is to quickly and accurately get the data out. As a result, the access layer is typically, although not always, modeled in dimensional form. The fourth layer is the delivery layer, seen here in blue. It represents all access paths by which a business user may access the data. Note that because the access layer is designed for how the business views that data, all interaction with the data is through that access layer. To understand the need for the split and how the data is brought in versus how it's accessed, let's first review some common characteristics of the integrated data layer. Common characteristics of the integrated data layer include: it's not redundant, it's efficient for loading, and there's no repeated information. This is typically achieved by designing the layer in third normal form. It's abstract. Abstraction allows for reuse and multiple perspectives on the same data. An example of this is that you may have multiple different kinds of addresses. Instead of designing for every relationship between each kind, instead we abstract the data and model the relationship between parties and addresses at the highest level with a single construct. It's complex. The model should be able to handle all the nuances of the data, not just the main points. It's stable. The use of generalization and normalization tends to make the database more stable. New content can be added by populating new types in the database or adding new tables and columns, rather than tearing apart existing tables. And finally, it's designed for data integration. Combining all of these other characteristics creates a model that's best designed for the loading of the data. So given all these characteristics, let's look at a simple business question and translate how we would need to construct a query to answer it if we were to use the integrated data layer. Let's look at the simple business question. Should we continue to insure recreational vehicles? To answer the question, I need to look at my total loss and my percent of RVs insured that had claims filed for all RVs last year. The yellow highlight shows the entities from my integrated data layer that are required to answer the business question. If you look through how I traverse all the tables and joins, that's a lot that's required to answer my question. It's not an easy environment for the business user to understand or to model within a BI tool directly. What we really need is a separate layer that's modeled for how the business wants to answer this question and feeds upon all the information that we've loaded into our integrated data layer. That is why we need an access layer. In thinking through the prior slide's example, you may be tempted to say that the integrated data layer should be modified to make the navigation easier for the business user. But remember, we modeled the integrated data layer to support data integration, and that third normal form model served that purpose. You may also be tempted to make the BI tool do the work, force the navigation of the third normal form model within the BI tool itself. But most BI tools work best with a dimensional model, either a star or a snowflake, so there can be a lot of reworking of the model pushed into a particular tool to force it to work properly. And what happens if you have more than one tool in place, or you want to bring one in at a later date? You also want to think about where business rules should be stored. If you were to apply them in the integrated layer as part of your ETL/ELT process, a change in the business rule would require potentially significant effort, particularly if historical conversion is required, and would likely require a timeline that falls outside the user's expectation. If you were to apply the business rule on the BI side, you isolate that rule to the one access path. Again, what if a business user wants to use a different tool or analytic application to access the data? The business rule would need to be replicated again, resulting in maintenance overhead. So without this separate layer dedicated to business user access, you risk isolation, replication, and maintenance overhead. I want to take a minute to demystify the term semantic layer. You may hear a lot of this terminology: semantic, access, presentation, delivery layer. For the purposes of this presentation, the access layer exists on the data platform. That can be Teradata, Oracle, SQL Server, or whatever data warehouse platform your enterprise has. It's made up of views or tables with the purpose of presenting user-friendly structures to the business user, including the instantiation of business logic. The access layer is what's represented in orange. What we'll refer to as the delivery layer is represented in blue. It's the metadata layer that exists on the business intelligence tool itself. As an example, you might think of the universe in business objects, the framework in Cognos, or the schema within MicroStrategy. Both of these layers can be defined as a semantic layer, which is why we use the different terminology here to differentiate between the access layer and the delivery layer. Let's look at some common characteristics of the access layer. It's redundant. When we looked at our integrated data layer, we might have a customer dimension where we store the first name and last name separately. However, within the access layer, we can meet the business need for a full name entity that concatenates first name and last name. We can hold all three of those within the access layer. It's specific, whereas in the integrated layer, we had an abstract approach to party and address. Within the access layer, we can specifically call out each type of address, giving it a name and making it business user-friendly. It's simple. Where in the integrated layer, we had the third normal form model, which required a lot of joins to answer a simple business question. The access layer is specific, and we can use business users' terminology so that they understand the model and how to join between the different entities. It promotes consistency and reuse. Again, because the access layer is on the warehouse side within the database platform, it's consistent and reusable across all different access paths for the business user. And finally, it's designed for business questions. Whereas the integrated layer was designed for data integration and to get the data in, the access layer is designed for performance and reports. It's modeled for how the business views the data and how to answer their questions. Now let's look a little further into what the benefits are for this approach to the access layer. First, it is the primary entry point for data retrieval, which helps us in a couple ways. We can model it based on user access paths to simplify result retrieval. We can apply row and column level security so a user will have the same security applied regardless of the method by which he or she accesses the data. And we can model it for how BI tools prefer to access the data to achieve optimal performance and simplify the delivery layer within the BI tool itself. Second, it holds the business rules. By modeling business rules in the access layer instead of the delivery layer, we can reuse the logic across multiple tools or methods of access, and we can leverage the power of the database platform to achieve optimal tuning for predictable access paths. By modeling these rules in the access layer instead of the integrated layer, we can quickly react to changes in the rules without requiring a historical conversion or impacting base ETL. And by base ETL, I mean those jobs responsible for loading the integrated layer, because the access layer can be instantiated as either logical or physical structures, but either way, you benefit from isolating the business rules in the access layer instead of the integrated layer. And finally, it projects meaning onto the integrated layer. In the prior slide, we talked about how the access layer is specific. It allows us to present the data how the business views it using naming conventions and specific dimensional structures versus something like a party entity, but we can do this logically to meet the business need without replicating data. And because it is done within the database layer, we have many more performance tuning options available to us, minimizing the need for BI aggregates to achieve our requirements. Let's start with the column on the left in my integrated data model. I have account information held in two fact tables, header and detail, and a set of user profiles loaded into one dimension and split by type. These are modeled in third normal form. Moving to the access layer, I start applying my business rules. The business always looks at header and detail information together, and they only want to see the last 3 years plus current. So in my access layer, I combine header and detail into one financial accounts view, and I apply a filter on the open date. But now say my business rule changes, and they want to see the last 4 years plus current. If I had applied this filter in the integrated layer, I would need to go back to my history and physically reload the 4th year. However, because I've applied this rule at the access layer level, I simply change my filter and the new rows are available for business use. On the dimension side, the business always looks at primary users and secondary users separately. So I create two views off of my user profiles table to present simple dimensional lookups for each profile type. Now looking at the delivery layer within my BI tool, I simply pull in the fact view and the two dimensional views, and I'm ready to create my base reporting objects. There's no complexity to understand or maintain within the BI tool, and I can replicate this across multiple tools and return the same results. So if I look back at our simple business question from before of whether we should continue to insure recreational vehicles, with my dimensional model in the access layer, it's very easy for me to navigate the model and return the answer. We have 4 major design principles when modeling the access layer. Number 1 is reflect. Bring the data from the integrated layer into the access layer and apply basic meaning to the model. For instance, I can leverage aliasing to provide business context to the integrated layer concept of party. Number 2 is project. Apply row or column level security. I hide fields that aren't applicable to business use, such as audit and control fields from the ETL process, and apply meaning to slowly changing dimensions so that the BI tool can consume them. Number 3 is transform. Apply business rules to the data, such as filtering, pivoting, or other complex measures and calculations. And number 4 is conform. Apply business rules to your dimensions and model them in a way that the BI tool can consume. This includes concepts like denormalization and handling of recursive or ragged hierarchies. For instance, a recursive hierarchy is where I have an employee dimension, but that dimension includes employees that are also managers of other employees. I can use the access layer to unfold that recursive relationship to create separate manager and employee dimensions with the associated relationship. A ragged hierarchy is where not all levels of the hierarchy are populated in all cases. In my employee manager example, I may have a third level for supervisor, where some employees have a direct relationship to supervisor without a manager. Most BI tools cannot navigate this type of hierarchy, so I add a dummy no manager record to resolve the issue. Keep in mind that third normal form has tremendous value due to its flexibility and scalability, but it's best when partnered with a well-designed access layer that can simplify the path to insight. In the example here, you see a real-world report where we first modeled it against the third normal form integrated model, and then modeled it against the access layer, in this case, a star dimensional model. You can see how much simpler the sequel is and how much easier this would be for a business user to understand. So there you have it. To learn more about how semantic modeling can help your organizations, contact your ClaroView account executive or reach out to us on clariview.com.